Welcome to Spring LIB.
Okay, in this problem, we have two disks with different masses and different radii. So the total moment of inertia of the whole system is a summation of the moments of inertia for the two disks. They both have the expression 1/2 mr squared. So summing them up, plugging the numbers, we get 2.25 times 10 to the negative 3 kilogram meter squared, where this 10 to the negative 3 comes from the transformation of the centimeters into meters. Okay, for part B, we connect these two disks to another block. So for part B, the setup is we connect the block to the smaller disk, and after the block with mass smaller m has descended 2 meters, we're required to find the velocity of the whole system. Here we can use energy conservation. Initially, the block has an initial gravitational energy, which is given by mgh. Finally, there is a kinetic energy for both the block and the disk. So here mgh equals 1/2 mv squared, kinetic energy of the block, and 1/2 plus 1/2 I omega squared. This is the moment of inertia of the smaller disk. I'm sorry, moment of inertia for the two disks. However, we don't know the omega yet. We can find this by using the omega equals v over r. Here, this r have to be r1 instead of r2 because now the block is connecting to the first disk. So from this equation, there's only one unknown variable v. We can solve for it to get square root 2 mgh divided by m plus I over r1 squared. Plugging in the numbers, we get 3.4 meter per second. Okay, and for part C of the problem, well, the calculation is exactly the same, except for that the block is connected now to the larger disk, and so we need to change this r1 into r2 for in the expression for omega. So for this v, you simply change this r1 to r2, and plugging all the numbers, you can get v equals 4.95 meter per second. This velocity is larger than the previous one because, well, the two disks, since they share the same center, they rotate together, they have to have the same angular velocity. And with the same angular velocity, the one with the larger radius will get a larger linear velocity or tangential velocity. That's why in the second case, you get a larger